Greatest common factor. Yeah. One of the things that we do in math is try to figure out what's the biggest number that divides two different numbers. So if I have 126 and 144, what number could I divide both of those by? You probably can see that you can divide them both by 2. But the question is there a bigger number that I can divide them both by?
Does it have to be a whole number?
Yes. So when we're looking for a factor, we're looking for a whole number factor. Because you could divide by anything then otherwise, right? And get some weird decimal as an answer. But when we're looking for a greatest common factor, we're looking for a whole number that does that. Now, you could just figure out everything possible that divides 126 and 144 and list all the factors possible and then see which one is in common. Okay? The problem with that is you might miss one, and if you miss one, you might miss the fact that that's the greatest one. So method 1, just writing out all your factors, saying I know that 144 is 1 times 144. It's 2 times 72. Okay? So 144, 1 times 144, 2 times 72. Can you divide it by 3? Yes. 3 times, and you have to get out your calculator, and it's going to be 3 times 48. It's 4 times, can you divide it by 4? 4 times 33. No? 34. No. 36. 4 times 36. Can you divide it by 5? No. Can you divide it by 6? Yes. 6 times 24. Can you divide it by 7? No. Can you divide it by 8? Yes. 8 times 18. Can you divide it by 9? Yes. 9 times 16. Can you divide it by 10? No. 11? No. 12? Yes. 12 times 12. And once the second number is the same or less, you're going to be done. Because if you go up any more, if I tried 13, well, it would have to be 13 times something less, but I've already tried everything up to 12. So this would be done for 144. $126. Well, so 1 times 126. Can you divide it by 2? Yes. 2 times 63. Can you divide it by 3? Yes. 3 times 42. Can you divide it by 4? Yes. 4 times. Wait. You can't divide it by 4. That's right. Can't divide it by 4. Shoot. So then you try 5. Can you divide it by 5? No. Can you divide it by 6? Yes. 6 times 21. Can you divide it by 7? 7 times 18. Can you divide it by 8? No. 9? Yes. 9 times 14. 10? No. 11? No. 12? No. 13? No. 14's already done because it's here. So we would, because we've tried everything up to 14 and now 14's on this side, we would know we were done. What is the greatest common factor of all the list of numbers in the 144 and all the list in the 126? Which is the biggest number that divides both of them?
Are we looking on both sides or just the left?
We're looking, here I'll split them up here. We're looking for the number in common between these ones and these ones. 2 is a number in common, but is it the biggest one?
But like, can it be on both sides of the times?
Yeah, it's any one of these. I just made 2 columns. What's the biggest one? 18. So that's one method. That method is exhaustive because you find everything. It's also exhausting because you have to find everything. So is there a method that lets us figure this out quicker? Yes, there is. And that method is method 2, is if we write the prime factorization of both of these numbers. So 144 and 126. We did 144 already, so I'm not going to redo the factor tree. Do you remember what it was? Was it 2 to the 4, 3 squared? Look back at our notes. Yes. 126. You know that that's 63 times 2. 63 is 7 times 9, and 9 is 3 times 3. So 126 is 2 times 3 times 3 times 7. And 144, if I write them all out, is 2 times 2 times 2 times 2 times 3 times 3. In the prime factorization, what do they have in common? They both have a 2. They both have 2 3s. What's 2 times 3 times 3? Greatest common factor, 2 times 3 times 3, 18. I like that method. Because if you find the greatest, if you find the prime factorization, which we can do a factor tree to figure out, and isn't the quickest, but it doesn't take forever, then we can use that to figure out the greatest common factor. Okay, I'm going to give you one that is bigger. $504 and 756. What is the biggest number that solves both of those? Once you've done your factor trees, and here is the ability to check, what is your greatest common factor going to be? Well, how many 2's do they have in common? A 2 there, a 2 there, a 2 here, a 2 here, then we're out of 2's. Then we go to 3's. We have a 3 here and a 3 here, a 3 here and a 3 here, then we're out of 3's. And finally we have a 7 here and a 7 there. So our greatest common factor is going to be 2 times 2 times 3 times 3 times 7. Multiplying those all out, $252. Did I know that I knew that it would be a big number.
No, but did you know that 504 was 2/3?
Did I know that it was 2/3? I didn't put it in as 2/3 of one of the other ones. But now that you see, you could look at that and see that the 2 and the 3 there, that it is 2/3. Yes.
I thought you did intentionally.
What I did intentionally is I made them both multiples of 63. So that our greatest common factor would be at least 63. And then I multiplied 1 by 8 and 1 by 12. So then it would be 63 times 4,